Good morning. I am Sgt Villar, and today I'll be presenting you with block instructions on converting azimuth. All right, the material here and the information is unclassified. And as you can see, I have my my risk assessment, my task conditions and standards, and my outline. All right, risk assessment today is slow. Please always ask for people to maintain situational awareness in case of a fire. We will follow protocol and rally in the front of the building, as well as if there's an active shooter. Let's not forget that run, hide, or fight. Yeah, stay hydrated, please. Be careful with any trip hazards, and if you're falling asleep, just walk to the back and pay attention. All right, perfect. All right, so today's task is converting azimuth. Okay, the condition is you'll be given, it is in a class environment, and you'll be given a standard 1 in 50,000 scale military map with declination diagram, pencils, a practice sheet, a magnetic azimuth, and a grid azimuth. Okay, the standard will be is converting a magnetic azimuth to a grid azimuth and a grid azimuth to a magnetic azimuth without error. No mistakes, I have to emphasize that. In accordance to the Field Manual 3-25.26. Okay, so let's start with the class. In order, preparing for tactical movements will often require a squad member to convert azimuth, and we all have to understand that it could be anybody, of any one of us. So we need to be prepared and have that knowledge there. You cannot just slack on, especially if you want to know where you're going, right? So accuracy is highly important because you don't want to end up in the wrong place. All right. Now, just to make sure that everybody is in the same level of skills, I'm going to go over a few concepts, okay? Let me start by saying, true north. The true north is actually the North Pole, but it doesn't have much navigation utility. So we're going to just mention it, but we're not going to use it, all right? So now you have these lines from north to south, and this is a map. Obviously, everything is gridded, and therefore, that is called a grid north, I'm sorry, okay? Now, when you have a compass, you have that needle that's magnetized, all right? And that will point to your magnetic north. So we got the true north that we're not gonna be using at all. We got the grid north that is displayed on the map because it's actually a grid. And then we have a magnetic north that you get it through the tools that you're carrying, which is your compass, all right? And these the grid north and the magnetic north, they tend to have a slightly different angle depending on what part of the world you're in. Okay, it changes too. And also another thing that I want to bring up is this little diagram here. You usually find it on the bottom of a map next to the scales and all of that, and it's the declination angle. We'll talk about that in a little bit. But the declination diagram, I'm sorry. All right, that's a very important tool that's going to be part of how we're gonna proceed to accomplish the task today. Okay. So in aviation math, by the way, this is usually called magnetic variations, just in case you end up crashing. Anyway, so the difference between a grid north and a magnetic north is called the grid magnetic angle. So this difference is called the grid magnetic angle, otherwise called also GM or GM angle or G angle. So this angle obviously will vary depending on where you are in the world, right? The magnetic north that we use to compass with actually moves easterly by 0.1 degree every 4 years. So as you can see, the information here is very important because this one is telling you that this information is from 1960. So you have to make sure you have an updated one. This is about more than 50 years ago. Yeah, more than 60 years ago. So that's one important detail you have to keep always looking after. Either way, you know. Anyway, another concept I wanted to touch is azimuth. What is azimuth? The word is even hard to pronounce. I had trouble with it, so I had to look it up. You know, the word is Arabic. It's not even English. It's Arabic, okay? And what it means is the direction. All right. So funny thing, right? Azimuth is the most common military method to express direction. So you're gonna hear that a lot, obviously, right? But azimuth is the angle form. All right. Let me put this out here. All right. All right. Azimuth is the angle form between a north baseline and the line that the subject or the the observer, okay, makes to a point of interest. So in this case, the observer is here, and he has some interest somewhere along that line. So that is what is an azimuth. An azimuth, you will be talking in degrees, all right, in reference to the baseline. All right, so the baseline, the north baseline, could be aligned with any of the norths that we already talked about, the true north, the great north, or even the magnetic north. All right, but that is just a baseline, a reference line. Perfect. All right, let's grab an example. Let's say you aim your compass to a distant point, right? And your compass reads 190 degrees. That will be your magnetic azimuth. All right, your magnetic tool has just given you an azimuth is a magnetic azimuth. All right, so 190 is a magnetic azimuth. All right, so now you want to take that information and convert it into a grid azimuth, which is, you know, from the compass to the map. So what do? All right, so if you know your GM angle, which is always going to be in that map that you're trying to convert, you know, on the bottom. All right, for this purpose, let's say it's 9. For the purpose of this training, it says 9. Your GM angle is 9 degrees. All right, you will be adding to the you'll be doing either adding or subtracting your GM angle to your magnetic azimuth. All right, now this all depends whether you add or you subtract, whether the GM angle is westerly or easterly, as you can see there. Okay, all right, so let's do this example real quick. All right, so we have, let me see with my, oh, there it is. So we have, the information we have is, we have a magnetic, okay, magnetic azimuth, AZ, equals 190, okay? And we have the GM angle that equals 90 degrees. Now, if we are going to convert our magnetic information into, so we could use it in our map, all right? And we have, and our GM angle is easterly, okay? We are going to actually add, all right? So easterly, all right, we're gonna be doing 190 degrees plus 9 equals 199. All right. Now, if we are western side, on the westerly, and we want to do the same thing, you know, we have our magnetic information. Now we wanted to transfer it to the grid, convert, you know, magnetic azimuth to the grid azimuth. What we do is westerly, we're gonna subtract. All right. Simple. Oops, sorry. Subtract. Remember that. That seems simple. Now what happens if it's the other way around? What would do it the other way around? Oh, let me go on this side. On the left handed. Alright, so if you want to convert your magnetic, the only information you have is a grid azimuth. Alright, so you have a grid azimuth for AZ. Alright, and it's the same information for purpose of simplicity. It's 190 degrees. And we look at the map because we always have a map, right? And we look and we have a GM angle of 9 degrees. So what happened in this case? So if it's easterly, we're going to subtract. So easterly, right? It's 190 minus 9 degrees equals 181 degrees. The same thing for if it's westerly. If it's westerly, it's not the same thing. Actually, you have to, add the GM angle, which will make it into 199. Pretty simple math, right? Hopefully, you do understand that this is not done in a simple environment. It's we probably end up doing it under stress. Therefore, one simple number, one digit could really throw us off. We need to make this right. We can't make mistakes. We can't afford to make mistakes with this. Okay? Anyway, I got something easier so you guys could remember. It's called mnemonics, right? So, this is, alright, so, as you can see, if you're trying to put your compass, alright, your compass information to the map, alright, you will see where your GM angle is, okay? So this is easterly and this is westerly. The easterly obviously is on the left and the westerly is on the right. So left add, right subtract. How about that? So if it's compass to map, you want to left add, right subtract. So if mapped to compass, you right add, left subtract. Hopefully, that'll be some information. But the more you do it, the less you have to remember that, because it's just all about practice. All right. Any questions? Any questions? This is pretty simple. It's just a matter of practice. Does anybody have any questions? Okay, perfect. So now what we're gonna do, you have the practice sheet with you. You have a pencil, and you have a map, right? So what we're gonna do is about 15 to 20 minutes of practice. This is very important for you guys to practice until you get it right. We're gonna keep on doing it until you guys get it right. All right. There's no point of rushing. It's simple math, but we want you to get to make sure this is second nature. All right. All right. This is the time actually to ask any questions. I'll be going around to make sure that everybody's doing it correctly. I'll let you know what you did wrong, how to correct it. Okay. So please start doing the practice. All right. If you have any questions, just raise your hand and I'll get there. Okay. All right. Perfect. Okay, we are going to do an assessment. It's going to be a 4-question assessment, and in order to get a go, you have to have all 4 questions correct. All right. It only takes 1 question to get it wrong, and it doesn't, and you're a no-go. If that ever happens to anybody, we'll retest, okay, retrain and reassess, and we'll see what happens from there, okay? I will pass a sheet of papers with the 4 questions around, all right? And you have 20 minutes, starting now. All right, your 20 minutes are up. Thank you, everybody. Please pass the sheet of paper to the center of the room. I'll collect them. All right, perfect. Thank you. This You guys did great. Everybody is a go. All right. So your task proficiency will be a T for train, and I'll report this to your chain of command. Please bring all the materials up to the front and leave it in the respective area box. All right. And I would like to talk about a little bit about the risk assessment. I'm glad that nobody got hurt as much as we walked today, and you know, some trip hazards and nothing else, so we kept it at low. All right. We our task today was to convert azimuth, and you guys did awesome. Everybody is a go, so we accomplished that task. All right. As far as the AAR, any sustainments, anything you thought that you know that we should keep? Thank you. Any improvements that you think we should work better on this? Thank you. All right. Finally, any questions? Do you have any questions for me? And concern with the azimuth? Okay. Thank you. All right. Well, this concludes our training for today. I really appreciate you guys being here, and now we'll be I'll be available for any questions after this. Okay. All right. So I'll be taking down my things.